In this question, we can imagine that the profits were $100 in the first year. That would mean we can write the profits for the second year as the following, and the third as this expression. We want to know whether the profits were higher in the third year than the first year, namely whether this inequality is true. We can simplify by dividing both sides by 100, getting the following inequality. Notice that the first year profits will cancel on both sides of this expression, whatever they are, so choosing $100 for the first year caused no problems. This last expression is what we want to know. It's what the question is asking us. Having done this, we can turn to the data statements, looking at them separately first. Statement 1 can be simplified a bit by subtracting 1 from both sides and getting the signs sorted out. Therefore, statement 1 tells us that x is greater than y. To compare this with the statement that we need to evaluate, we can consider cases. Since we are talking about percentages, x and y could range from a number very close to 0 all the way up to 100. For example, if x were close to 100 and y were close to 0, then x would be greater than y, so we're dealing with an allowed case. And then x over 100 plus 1 would be close to 2, and y over 100 subtracted from 1 would be close to 1, and the product of the two would be greater than 1. It would be about 2. In such a case, the answer to the question posed would be yes. Then we need to try to construct a case that is valid according to statement 1 and which yields a no. This can require some trial and error. To try to make the effect of 1 minus y over 100 as large as possible, we could choose a quite large y. One way to do this is to choose y equals 95, still keeping x as 0. Then 1 plus x over 100 is 2, and 1 minus 95 over 100 is 5 over 100, or 1/20. So the two multiplied together is 1/10, and we have a number that is less than 1. We don't have enough information to answer the question definitively, having obtained valid cases for yes and no, so statement 1 is insufficient. This part of the question is an example of how analysis by cases might sometimes generate a situation in which you are potentially stumped and not completely certain whether you are missing a more relevant case. In this type of situation, you'll have found one or more cases that all yield a consistent result. You might not have found a case that yields a contrary result, and you're trying to decide whether that means there is no case that yields a contrary result, or you're just missing it. One technique to be sure that you are trying as complete a range of numbers as possible is to try big numbers, small numbers, integers, fractions, positive, negative, even, odd numbers. Another technique is to try to learn from the cases as you go. You might notice a pattern that allows you to finish the analysis. Sometimes, whichever way you go, it will be necessary in the interest of time to make a decision without being 100% certain, although we were in this case. Moving on to statement 2. This statement bears some similarity to the question we are attempting to answer. We can go back and multiply out the left side of our expression of interest to get the following. Here we can subtract 1 from both sides, and then we can multiply both sides by 100, getting the following expression. Comparing this with statement 2, we can see that statement 2 is presenting us with the fact that is exactly what we are looking for. Since statement 2 tells us that this inequality is true, the answer to the question posed will always be yes. Statement 2 is therefore sufficient. The correct answer is B.